In the traditional world of physical logistics, there is a brutal, unbreakable rule. Scale breeds friction. The larger an operation becomes, the slower and more complex it gets. As linear supply chains stretch across oceans and continents, every handoff point acts as a toll booth. A delay at a single port compounds into a massive backlog by the time goods reach the final destination. This 20th century model was plagued by structural blind spots. Goods sat idle in warehouse bottlenecks, waiting for manual sorting. Companies relied on rigid, third-party freight handoffs, where they lost all visibility of their inventory for days or weeks at a time. But modern e-commerce giants present a glaring anomaly. They have expanded their physical footprints to a global scale, and yet, instead of slowing down, their delivery times have aggressively contracted. This chart illustrates the paradox. Over the last decade, total fulfillment volume has exploded upward, while the average delivery time has plunged in the opposite direction. This inverse correlation defies traditional commercial logic. To understand how millions of daily orders are processed and delivered in hours rather than weeks, we have to deconstruct the hybrid infrastructure, where digital code orchestrates physical steel. To analyze how this is achieved, we look at this master's thesis evaluating e-commerce supply chain efficiency. The researchers selected Amazon as their case study to analyze its massive supply network. The data reveals the primary drivers are the integration of digital commerce technologies and cloud-based inventory management. Deploying these systems achieved high operational flexibility, securing a global competitive advantage. To replicate this advantage, we need to examine the mechanics of this system. We are going to map out how specific technological software layers direct the heavy hardware of modern logistics. This diagram shows a traditional supply chain. It operates as a strict, linear sequence, from factory to port to warehouse to retailer. This creates a blind relay problem. Node B only knows what Node A hands it. A warehouse manager has zero visibility into the factory's raw material shortages until the expected shipment simply fails to arrive. Because the nodes are isolated, a single disruption at the factory level triggers a cascading chain of delayed, reactive panic down the entire line. The academic research outlines a completely different architecture for modern e-commerce. Instead of a straight line, the chain is restructured into a hub-and-spoke network. Every physical node is directly wired into a centralized, cloud-based data layer. Information now flows omnidirectionally. The warehouse doesn't wait for a truck to arrive. It uses real-time, factory-level data to anticipate exact inventory volumes weeks before the goods even hit a cargo ship. Integrating data across all nodes eliminates the system's blind spots. It is the technical foundation for managing millions of moving parts across a global map without sacrificing delivery speed. However, data is useless if the physical assets can't move fast enough to act on it. The digital intelligence requires a highly specific, massive physical infrastructure. Look at this facility. Rather than building static warehouses designed to hold boxes for months, Amazon constructs dynamic fulfillment centers designed for rapid inventory turnover. Inside these centers, the primary bottleneck is sorting, finding and moving individual items among millions of stacked pallets. To solve this, the company replaced human transit time with robotics. Automated robotic forklifts and mobile drive units physically retrieve entire shelving towers and bring them to human pickers. This mechanical compression reduces the time between a customer clicking buy and a box being taped shut from hours down to minutes. But once the box leaves the center, handing it to a third-party postal carrier reintroduces the exact blind relay friction we discussed earlier. To maintain control, a proprietary transportation layer is required. This includes operating a dedicated cargo fleet. Rather than waiting for space on commercial flights, dedicated planes connect regional fulfillment hubs across the globe on schedules optimized entirely by the central data core. The fulfillment centers, the robotic floors, and the cargo planes are not separate businesses. They operate as a single, highly synchronized integrated circuit. Building this specialized hardware layer requires tens of billions of dollars. It represents a massive capital barrier that forces competitors to rely on the slower, traditional logistics networks. This chart illustrates the ultimate stress test for this infrastructure. Between 2020 and 2024, there was a massive, sustained surge in active users and monthly website traffic. Pushing that volume of physical goods through the system should have caused complete gridlock. Instead, the central data layer relied heavily on artificial intelligence and predictive analytics to manage the flow. The system utilizes a concept called anticipatory shipping. By analyzing regional search trends and purchase histories, the AI calculates what products will be needed and physically moves that inventory to local fulfillment centers before a customer actually places the order. Look at the resulting data here. While the total growth in units fulfilled continued to climb aggressively, the managed distribution costs flatlined. The software actively insulated the company from the expense of physical scaling. By anticipating demand and pre-positioning goods, the predictive software effectively shrinks the physical geography of the supply chain. The data from the academic study leads to a specific conclusion. Scaling an e-commerce operation requires a total, systemic restructuring of the physical supply chain that supports the digital storefront. The end result of welding predictive AI to automated physical infrastructure is exceptionally high operational flexibility. The system accelerates responsiveness to consumer demands precisely because it anticipates them. The companies maintaining an edge in modern commerce are those that stop treating logistics as a series of isolated shipping contracts and start treating their supply chain as a unified, networked digital asset. When you evaluate a modern retail operation, do not just look at their transportation costs. You have to analyze their logistics network as an integrated data ecosystem. Amazon's logistical framework proves that scale no longer has to guarantee sluggishness.